Hey, Algebra 2. This is lesson 56. Today we're looking at angles in circles. And first we have a couple of terms that we need to go through. Very simple terms. You can see the three that I have here on the first screen. The first is called a secant. A secant is a line or a segment that passes through the circle. And it intersects the circle in 2 points. Okay, so it passes through the circle, something like this. And it's going to intersect in 2 points. Okay? Now, it goes on and it extends out past the circle. Now, if you look at a line or a segment that starts and stops on the circle, it wouldn't be a line, it would just be a segment. If it starts on the circle and stops on the circle, if we have a segment that starts and stops on the circle, that is called a chord. Now, we have dealt with one special chord. If it passes through the center of the circle, then it is called a diameter. If you look up definition of diameter, it's just going to say it is a chord that passes through the center of the circle. Okay, so a secant passes through the circle, intersects the circle in 2 points. A chord starts and stops on the circle, connects any 2 points on the circle, sometimes passing through the center, but most of the time not. This last one is called a tangent. A tangent is a line or a segment that intersects the circle in 1 point. So this is a line or a segment that just is touching the outside of the circle. If you think about a circle and how it sets on a table or leans up against something, it's going to touch the circle in 1 point. So a lot of times we see it drawn something like this. That's not a very good line. Let's move that a little bit. So if I move this out to where it's just touching the circle in 1 point. Okay? This 1 point where it meets is called the point of tangency. Okay? This line or segment touches that circle in 1 point. Now, something else that we need to understand is if we look at the center of the circle and we draw the radius from that center to that point of tangency, that radius and that tangent line will always meet at a right angle. Okay? And there's lots of other properties we can get into in geometry dealing with the relationships there, but just know that a tangent line touches the circle in 1 point, and if you draw the radius to that point of tangency, it meets that line at a right angle. Okay, now we're going to put some of this stuff together and solve some special problems. Okay, so here's our examples. Now, we have 2 lines or segments that intersect either inside or outside of the circle. And when that happens, arcs are formed on the circle. So if we look at this first example, I'll call that number 1. Okay? I have 2 secants that intersect outside the circle. They intersect out here. And they form this angle X. On the circle, they form the 2 arcs, the 80 and 40. Okay? There is a relationship between those 2 arcs and that angle formed on the outside of the circle. It's very simple. This angle on the outside is equal to the difference of those 2 arcs. Difference is subtraction, so I subtract the big one minus the small one. I take the difference of those 2 arcs and I divide it by 2. Okay? Very simple. Subtract the arcs, divide by 2. That gives me 40 divided by 2. That angle on the outside, X, has to be 20 degrees. All right? So when the 2 lines or segments intersect outside the circle, you take the difference of the 2 arcs and divide it by 2. So subtract them, divide by 2. Now, the second example here, I have 2 chords, segments, that intersect inside the circle. Now, not necessarily on the center of the circle, but they intersect somewhere inside the circle. And they form this angle X. Now, I put 2 X's on there because we should know those are vertical angles, they're equal. And those 2 segments also form arcs, 40 and 80. Okay? Now, there's a connection between these 2 arcs and, these 2 angles, this angle X and the 2 arcs formed on the outside of the circle. We should know the relationship when that intersection is on the center of the circle, forming central angles, but this time it's not necessarily on the center. So to find that angle x, when it intersects inside the circle, instead of subtracting those two arcs, we're going to add the two arcs and still divide by 2. So when they intersect on the inside of the circle, it's kind of like finding the average of the two intercepted arcs. So you add them together, divide by 2. So that's 120 divided by 2. That angle x has to be 60. Okay? Now, one thing you got to watch here. Sometimes, as we get a little further along, we need to make sure that this angle x, we're looking at that arc and that arc. Every now and then, they'll give you some information about these other two arcs, but they want to know that angle x still. So you might have to work some stuff around to figure out those other angles or those other arcs so you can find the right angle. Okay, so just watch for that. Whatever angle you're looking for, you want those arcs that are formed by that angle. Okay, let's try a few more problems. I've got 4 examples here. Let's start up here. We'll call this one number 3 because it was the third problem. Where are the two lines intersecting? They are intersecting on the inside of the circle. When they intersect on the inside, you're going to take these two arcs. Again, I want the arcs outside from x. So when they intersect inside the circle, I add those two arcs together and divide by 2. So x is going to equal 80 plus 60 divided by 2. 80 plus 60 is 140. Divided by 2, that angle x has to be 70 degrees. Not too bad, pretty simple. Here's number 4. Where are the lines intersecting? This angle x is outside the circle. So when they intersect outside, remember this is where we take the difference of the two arcs. So this x equals, take the big arc 80 minus the small arc 30, divide by 2. 80 minus 30 is 50. Divided by 2, x has to be 25. All right, hopefully not too bad. These last two, I put these on here because they're slightly different, but very similar to this number 4. Let's look over here at this one. The reason I put these two on here is because sometimes one of those segments is going to be a tangent to the circle. So this line right here is our tangent. Now don't confuse that with sine, cosine, tangent. Slightly different, okay? It's a tangent line. When we have that tangent line, our point of tangency is here. We still have an arc formed, a 30-degree arc here, and a 70-degree arc out here. I look at where the angles are, or the line segments are intersecting. This angle x is here. Now, I also want to know that this angle is also x because they're vertical angles. So, again, ask yourself, where are the lines intersecting? These guys are intersecting outside the circle. So I need to apply the same property I did on number 4. When it intersects outside the circle, you subtract the two arcs. So it's no different here. I have 70 and 30. This angle x is going to be the difference of the two arcs divided by 2. So 70 minus 30 is 40 divided by 2. That angle x has to be 20 degrees. All right, same thing with this one. This last problem, number 6. This last problem, the concern I have is, let me erase this 6, get it out of the way. The concern I have is right now I only know one arc. It's 135 degrees. That goes from this point here, the point of tangency there, and I have another point of tangency here. So I have an arc on the inside. I also need to know this arc out here to be able to find x. Well, how am I going to find that arc? If you look at this picture, from this point of tangency around the circle to here is 135 degrees. Well, I also have the rest of the circle. So this arc is talking about the whole rest of the circle. How do I find that? Well, the whole circle is 360 degrees. The inside part is 135, so take that 360 and subtract your 135. When I do that, I get 225 degrees. So that tells me this arc on the outside is 225 degrees. Now that I know that arc, I can find angle X. Again, ask yourself, where are the lines intersecting? They're intersecting outside the circle, so I'm going to subtract. That X equals 225 minus the 135 and divide by 2. Don't forget to divide by 2. So 225 minus 35 is 90. Divided by 2, X is going to be 45. Okay? So hopefully that wasn't too confusing. Remember, if the two segments intersect inside the circle, take the two arcs, add them together, divide by 2. If they intersect outside the circle, take the two arcs and subtract and divide by 2. That gives you your angle X. Okay? That's all I got from lesson 56. Good luck.